titled What is Bitumen? I'm Ian Lancaster, the technical lead for Bitumen, and my aim today is to give you very much a flavour of a really fascinating engineering material. And I hope that at the end of it, you'll have a bit more of an understanding and appreciation of just how important and special this material is, how it's produced, how we test it, and a little bit on how we specify it and what we need to know about it. Now, Siobhan has already made mention to the fact that this meeting is carried out under Bitumen compliance guidelines and the Bitumen data protection policy. They were attached to the webinar invitation. And the presentation itself will be recorded, but not the Q&A. Okay, so let's go and have a look at what bitumen is. Now, it's difficult in an online webinar to get a discussion going, really. Normally, if we were in a face-to-face presentation, we'd have lots of interaction. But if we were to go out and ask those of you that are in the audience today what bitumen is, then I would guess that most would say that it's a vital component in asphalt mixtures, and that's absolutely true. Many people say that I have a biased view because I'm in the bitumen industry, but I would argue that bitumen in an asphalt mix is probably the single most important component. Why? Because it's the glue that holds everything together. And if the bitumen doesn't do its job, then the asphalt can't do its job. It really is that important. Sometimes, however, we maybe forget that bitumen is also a waterproofing material. It's a hydrocarbon material in nature, and as a consequence, it's very good at keeping water out of structures. So it will keep water out of asphalt materials, but also it will give waterproofing properties to roofing felts, waterproofing membranes, shingles, those sorts of things. So it's designed to protect construction as well from the ingress of water. Perhaps less well known is the fact that bitumen is an insulating material. It's used for insulation of electrical cables, but it's also used in sound insulation in combination with fillers. It can reduce the transfer of sound, and we typically find those sorts of materials in cars and vans and lorries, where it deadens the sound that comes from the engine. And finally, we also want to stress that bitumen is a sustainable material. Now, that might seem odd, given that it's a petroleum-based material, and there are a lot of pressures on manufacturers of petroleum-based products at the moment to demonstrate their sustainability criteria. Well, it's very important to remember that bitumen itself is sustainable because it's one of the very, very few components from crude oil that isn't burnt. We don't burn it, and it is fully recyclable in whatever material it goes into, whether that's asphalt. Within the asphalt industry, we've got a very, very good record of using reclaimed asphalt planings, putting them back into new asphalt, and really driving forward that circular economy. So it's important to remember just what the sustainability credentials of bitumen are. And then finally, we must remember that bitumen is not a waste. It's a precisely refined, produced, controlled product. And it's well established. It's been in use. Petroleum bitumens have been in use since the late 19th century, or early 20th century, and still in use today as we're in the 21st century. So it has a proven track record. Now I want to give you a flavour now of where bitumen is used. And I've already touched on some of the big uses of bitumen in paving and in roofing and waterproofing membranes and insulation. But you may be surprised just how much bitumen there is out there and where it is and the sorts of materials that it goes into. So yes, paving and bridges, a huge use of bitumen. Airport runways and standing areas, again, paving. And we've mentioned roofing felts and flooring materials, but also sound insulation, pipe coating. Bitumen provides fantastic levels of insulation for undersea pipelines. It can provide thermal insulation. It can be used as a briquetting and an agglomeration material so that we can compact wastes. It's used in wood protection. One of the very earliest uses of bituminous binders was to protect wood. So it's absolutely all around us, this fascinating engineering material. Everywhere you look around you in the environment, you will find there are bituminous products absolutely everywhere. But if we drill down a little bit, then you can see just exactly where the big volumes of bitumen are, and that is in paving. It's approximately 85 to 88% of the total global bitumen demand goes into paving. And again, that reinforces the credentials of bitumen as a sustainable construction engineering material. Roofing is the next highest consumer, roofing and waterproofing. And then we have those very niche applications that we saw in the slide previously. Things like agglomeration, printing, pipe coating, wood preservation, even agriculture. But by far, the biggest single use of bitumen is in production of paving materials, whether that's surfacing materials or subsurface materials to give the road its strength and its engineering properties. So let's have a look around just in a little bit more detail, just to reinforce that really. If we look at a model town or a model area of a town, where might we find bitumen being used? Well, within our model town, we've just established a road, and most often that will be constructed using asphalt. And we have asphalt lower layers, and we also have the surface. And those two types of materials are designed to do two different things. The asphalt in the lower layers is designed to give strength and resilience. The asphalt in the surface layer is there to give ride quality and to conduct water and to conduct noise away from the structure. So we find bitumen in those two asphalt layers. What about when we start to build around these roads in our model city? Well, again, we'll find the bitumen used in roofing membranes on both flat and pitched roofs. There to, in the first case, of a flat roof, to stop any penetration of water through the roofing or waterproofing membrane into the structure beneath. And on a pitched roof, it's there to conduct the water away while at the same time maintaining the integrity of the structure that's underneath. We might find specialist applications, specially modified bitumen, special types of asphalt that require particularly newly designed properties for the bitumen to generate suitable properties for a car park outside of the building. And then finally, we'll find the bitumen in waterproofing membranes. And this is different. So here, what we're looking for the bitumen to do is to stop the water coming up and inside the building rather than penetrating it from below. And if we don't do that, and if the bitumen isn't capable of doing that, then we run the risk of the structures beneath starting to deteriorate. And it's good that bitumen can do such a great job in preventing water ingress that it's used to protect these structures. So how would we describe bitumen? Well, there are a number of different ways. If you go to any dictionary, you will find a typical description, and it's very vague. It will talk about a black to brown material, which is highly viscous, and it's obtained from the residue of processing suitable crude oils. And there's a key word there, and that's suitable crude oils. There are a number of different crude oil sources across the globe, but of those, not all are suitable for producing bitumen. So there we are. We have a very vague description of bitumen, and it doesn't tell us a great deal. We could look at the chemical definition. Here we're taking this from the European Chemicals Agency and the REACH regulation. And how that describes bitumen is a very complex combination of high molecular weight compounds containing carbon numbers greater than C25. So that's a chain of 25 individual carbon atoms, or a ring of 25 carbon atoms, or a combination of the two, with a very high ratio of carbon to hydrogen. And it may also contain small amounts of metals, such as nickel or iron or vanadium. That's the chemical definition. But if we were to, again, run a little interactive session here, these are the words that would come up. Recyclable, waterproof, temperature resistant, chemically resistant, long life, reusable, recyclable, insulating, easy to mix. So there are any number of ways of describing bitumen, and they all contribute to our understanding of what this material is and what it does. So there are a whole number of different ways of describing the material, from the very vague dictionary definition to the very highly technical chemical definition to the description that many people in the business would have, and they all contribute to that understanding. So I hope I've given something of a basic introduction there into what bitumen itself is, and now I want to move on to the second stage and talk about bitumen production methods. Now, there are a number of different methods of producing bitumen, but for the purposes of today, I'm just going to concentrate on this very first one, which is atmospheric and vacuum distillation. Still the most common bitumen production method worldwide. And so we're going to describe how this process works and what we get at the end of it. The other production methods we have on our radar to describe in later external webinars. So let's look at the principle of distillation. First thing that we have to have is our feedstock. So we can imagine a crude oil tanker comes across the sea and puts crude oil into some storage tanks. From there, the crude oil is passed into a furnace, and the role of the furnace is to increase the temperature to around 300, 350 degrees and take some materials out. We're left at the end of that first column, if I can just pause perhaps. Oops, let me pause. And I'm just going to go back ever so slightly. So we heat our incoming crude oil in the first furnace to about 300 to 350 degrees. And we pass that into what's called an atmospheric distillation column. What happens in that atmospheric distillation column is some of the lower boiling point materials that are in crude oil start to evaporate, and they rise up the column and are removed and taken away for other products and other processes. We're left then with a residue, which we then pass into a second furnace. And the role of that second furnace is to increase the heat a little bit further. So we're looking typically 330 up to about 400 degrees. And then the residue there passes into a second distillation column. This time it's what we call a vacuum distillation column. It operates under reduced pressure, and that allows the more high boiling point materials to be removed. And what we're left with at the end of that process is a straight run bitumen. And we can take it from there and place it into a storage tank, and then we can deliver it out to customers in the asphalt or the waterproofing world. And that could be the end of the process, but it doesn't have to be. There are other processes. We can take the bitumen and we can add polymers to it. Oops, sorry, that's gone a little bit. Oops, that's gone bad. Let me start again. And we'll bring this across. So we can take our straight run bitumen and we can add polymers to it, change the properties, and then we can deliver a polymer modified bitumen. So we've changed the properties of it. We can also take that straight run bitumen and pass it through an oxidation unit to produce stiffer, harder, higher softening point materials, which are used in the roofing and waterproofing industry. That gives us our oxidized bitumen, which we can then transport and send out or subject to secondary processes. And that's the process. That's the sort of process that crude oil experiences from delivery to a refinery, being subject to atmospheric and vacuum distillation, and then some other secondary processes. But we're not going to talk about those secondary processes today. We're just going to focus on the distillation process. So let me show a little bit more detail here and describe the distillation process in a little bit more detail. So our crude oil comes in from the tank and is passed into a furnace where it's heated to approximately 300 to 350 degrees. It emerges from the furnace into the atmospheric distillation column, and the low boiling point materials rise up the atmospheric distillation column, and they could be gases, they could be light oils, distillates, kerosene, that sort of thing, and they're taken away to other refinery units. Our residue at the bottom of the atmospheric distillation column is then passed through a second furnace. The temperature is increased again, and then we place it into a vacuum distillation column where we reduce the pressure significantly, and that allows the heavy boiling point materials, the high boiling point materials, to rise up that column, be separated out as distillates and oils, and then at the bottom of that column, there we are left with our straight run bitumen. And it's the vacuum distillation column that does the majority of the work. The grade of bitumen that's produced at the end of this process is dependent to a very great extent on the temperature in the column, the pressure in the column, and the time that the residue remains in that column. Now, it is possible to operate that distillation column to produce every single grade of bitumen that you may want to produce. But in this respect, bitumen is actually quite a forgiving material because you don't actually have to do that. You can take hard bitumens and soft bitumens and blend them together to give you intermediate grades. Now, as you can see on the graph here, we can blend from our 35 penetration up here to 190 penetration, and we can produce those intermediate grades there. Now, I want to introduce a note of caution here, and this is very, very important, that this blending graph that you can see in front of you and the equation down at the bottom of the screen, this blending graph is only applicable to unmodified bitumens, and equally it's only applicable to materials of known origin. So it's important to remember that if you have developed a blending chart like this one for two different grades of bitumen of known origin, if you take a bitumen of an unknown origin, it may well not follow those blending rules. So it's very important to recalculate the blending chart and make sure all of the rules that you've already established actually work. So that's a critical takeaway from the session today, is that the blending chart only applicable to unmodified bitumens, and it's only applicable to materials of known origin. Having produced our bitumen, we then have to have a means of specifying it, and we have a number of product standards within the EU, covering all of the bitumen grades that we want. The paving grade bitumen, EN 12591, covers those materials that are typically used in asphalt. Then we have a hard paving grade bitumen specification, EN 13924 Part 1, and that covers stiffer, harder bitumens that are used more regularly in those structural layers, the subsurface layers of an asphalt. And then we have a range of different specifications for other materials, such as oxidized bitumens, hard industrial bitumens, emulsions, polymer modified bitumens, and bituminous binders. And it's important to remember that most of these specifications, these product standards, are based on what we call empirical properties. And I'll come to that later. So they don't necessarily indicate how a particular bitumen will behave in a particular set of circumstances when it's in the construction works. But as an industry, we are working towards developing specifications that will allow us to do that. But it's a very difficult and it's a time-consuming job, and we need to be absolutely certain that anything that we propose towards performance testing will actually work. So we are working very, very hard on that. To build a specification, we need to understand certain properties and certain behaviors of bitumen. First of all, we need to know about how bitumen behaves at normal or ambient temperatures. And the test we use for that is needle penetration. This is the oldest of all the bitumen tests. It's 134 years old, and it gives us a very basic measure of the stiffness of bitumen under very precisely defined conditions of temperature, load, and time. So what we do is we produce our sample of bitumen that you can see here. We condition that down, firstly in air and then in water, to 25 degrees Celsius. Then we bring a needle to rest exactly on the surface of the bitumen. We can't allow the needle to penetrate, and we can't allow the needle to be above the surface of the bitumen. Otherwise, we get a result which is false and is not valid. So we bring the needle to rest exactly on the surface of the bitumen. We apply a load of 100 grams to the needle, and then we allow that needle to fall into the surface of the bitumen under that 100-gram load for a period of 5 seconds. And the depth of penetration, measured in tenths of a millimeter, is what we would call the pen value, or the pen number, or the penetration. So if someone talks to you about a 200 penetration bitumen, what that means is that at 25 degrees, under a load of 100 grams for 5 seconds, this needle will penetrate the surface of the bitumen for 200 tenths of a millimeter, or 20 millimeters. And that's the oldest of our bitumen tests. We also need to know about how bitumen is going to behave at higher temperatures, because as we heat bitumen up, it becomes more fluid, and we can get to a point where the bitumen becomes completely fluid, and that's known as the softening point, more correctly, the ring and ball softening point. And this is the second oldest test for bitumen. It's been in use since 1916. It involves filling 2 rings with a precise amount of bitumen, allowing those samples to cool down, and then any excess is removed from the surface of the rings. We then cool those 2 rings down, transfer them into a frame, which you can see here. Mount the frame into a beaker and place the beaker onto a heating device. And then we increase the temperature of the beaker at a very precisely defined rate of 5 degrees per minute. And as the bitumen starts to heat up, the ball, which is placed on the surface of the bitumen at the start of the test, will start to sink through the ring. And when it touches the bottom, that's the softening point, the ring and ball softening point. And that gives us an indication of the high service temperature end of the bitumen. And we need to know that to make sure that the bitumen will perform at high temperatures. We also need, if we are involved at all in using bitumen and mixing it or pumping it or delivering it, we need to know about this. And we test a property called viscosity. And this is fundamentally important because it defines pretty much everything that we do with regard to handling bitumen. It defines how we pump bitumen around a refinery, how we load bitumen from a storage tank into a delivery vehicle. It defines how we move the product from a delivery vehicle into the storage tank of, for example, an asphalt plant. It then defines the temperatures at which we will get effective mixing. And it's so very, very important to understand about the viscosity of bitumen, because it affects everything that we do in terms of handling. Now, we have two different methods of assessing the viscosity of the bitumen. We can use what is called a capillary viscometer here, and we can measure the viscosity at some precisely defined temperatures, either 135 or 60 degrees. These are the oldest, and they tend to give us only very discrete information. So they can only give us information of the viscosity under precisely defined temperatures. However, we are starting to move now more into this type of equipment, which is known as a rotational viscometer. And the beauty of a rotational viscometer is that you can measure the viscosity of the product across a range of different temperatures and a range of different shear rates. So you can get a full profile of the behavior of the bitumen when it comes to mixing and pumping and storage using that one piece of equipment. And eventually we feel that specifications will move across to measuring the viscosity of the bitumen using a rotational viscometer. Not specifically for today, I've just covered the very basic tests. When we do more of these webinars for the future, we'll look at some of the more sophisticated, some of the more performance-related tests, and how they can be used within specifications and what they mean for the bitumen itself. And so at a later stage, there are other things that we will need to cover. We need to think about the aging of bitumen. It's an interesting material is bitumen, because it's affected by heat and it's affected by air. And so every time we move it about, if we run the risk of incorporating heat and air and aging the bitumen. And what we need to know is how much does the bitumen age in those processes. And we can measure the aging on a short-term effect to give an idea of how the bitumen will be aged in, for example, an asphalt mixing plant. Or we can carry out long-term aging, where we can try and simulate the aging that bitumen experiences in an asphalt material throughout its lifetime. We also need to know about the flash point of the bitumen. Is it safe to handle? At what point will the bitumen potentially catch fire? And we can measure that temperature, and from that we can then establish suitable mixing and handling temperatures to ensure that we don't approach the flash point of the bitumen. We also need to know about low temperature behavior. I've already spoken about intermediate and high temperature behavior, but as we cool bitumen down, it can become more brittle, and we need to know at what temperature the bitumen will become brittle so that we select the appropriate grade for the application that we're using. And then, just with a look to the future, we are moving towards rheological testing. Now, rheological testing is the future of bitumen testing, really. because it gives a lot of information from a single test. We can measure the stiffness, we can measure the elasticity of the bitumen over a range of temperatures, and it gives us some kind of performance-based indicators for how the material is going to perform. But those, I hope we will cover at a later date. So, in summary, what were we trying to do today with this first of our webinars? What I've tried to demonstrate is that bitumen and bituminous binders have got a very long, very rich, and very diverse history. They've been in use, depending on which historical sources you look at least since the late 19th century. And if you look at some of other historical references, they go back much further than that. So they have a well-established history. But from our perspective and from everyone else's perspective, we feel that it's bitumen, bituminous binders, bituminous materials have got an equally long future. They contribute to mobility. They contribute to protection of construction materials. So they will continue to contribute to the future. I hope I've given you a flavour of just how versatile the material is, and what it does in terms of engineering, and so many different applications that there are for bitumen and bituminous binders. It's not just asphalt. Asphalt is the biggest by a long way, but there are so many more different applications for this valuable, sustainable material. And also, I've tried to stress that bitumens are not waste materials. They're precisely produced and precisely controlled materials. And if you put all of that together, I think the answer to the question, what is bitumen, is it's a fascinating material. An absolutely fascinating material. I've spent nearly 30 years within the bitumen industry, and it still continues to fascinate me to this day. It will always throw some aspect of performance that you haven't seen before, or some property that you haven't seen before. So it really is a fascinating material. Where can you go for more information? Well, we've said that this webinar will be recorded, and it'll be placed onto our website so that you can access it. On our website, there's a whole host of information there, training documents, technical information sheets. These we developed to try and explain or give practical advice on individual test methods for bitumen. There are toolbox talks and HSE information to give you all the information you need to handle bitumen safely, and then the specification and standardization information. Equally, you can look at the Asphalt Institute in the States, European Asphalt Paving Information, and the Institute of Asphalt within the UK. They will give you a whole host of information on bitumen and bituminous binders. If you want more, this is our team within Eurobitume. Please feel free to reach out to any one of us in the team. And if we can't answer the question, we know someone that will. So those are our contact details. And again, they are on the website. So all that remains from me is to say thank you for your attendance today. I hope that I've managed to give you an insight into this fascinating engineering material.